Hi, this is Dr. Vaughn, and I'm going to try to make a video about your homework, Chapter 10, Part 1, question number 3 by request. So here I've loaded up the data table already. I clicked on this click to copy to table, and I opened the data set into Excel already, just to get a little bit of a head start. So we'll go back and we'll look first at the null and alternative hypothesis, which of course here we're going to look at the statement. Is there evidence of a difference? So that tells me that we're going to do a non-directional test, a two-tailed test, which means that the null hypothesis is that there is no difference. So the mean difference between the two is equal to 0, and the alternative hypothesis is that there is a difference. So the choice here would be A. Now we're going to move on and find the t statistic, and for this we're going to use the built-in function in the data analysis toolpack. So I'm going to pull up the data and the data analysis toolpack, and I will select the Ttest paired two sample for means. So we have two paired samples together, brand A and brand B. So I'll select the right test. We'll put variable 1 is going to be all the brand A scores. Notice I grabbed the label row which had brand A in it, and then for the variable 2 I'll grab the label again, make sure I click the label, make sure I put 0 in for the hypothesized mean difference, verify that my alpha level is correct. Here they said an alpha level of 0.10, so I'm going to set this to alpha level of 0.10, and that's about it. So I'll select the output range to be somewhere else on my table. Let's say, make sure I click in the box here, and I'll put the output down here below, and then I will click OK. So here's the output from our data analysis toolpack, and the t-statistic is negative 2.8736, negative 2.87. So over here they want 2 decimal places, negative 2.87. Now they want to find the critical values. So the critical values at the 0.10 level of significance. We can go in and just remember what those critical values are, or we can just go look them up again on this table. So in this case, we're doing a two-tailed test because, again, it was a non-directional. So the critical value for t-tailed, it's plus or minus. Because we're doing a two-tailed test, we have both sides. So it's plus or minus 1.86 to 2 decimal places, plus or minus 1.86, rounded 2 decimal places. So I'll put in the minus 1.86, comma, the positive 1.86. All right, now we compare the test statistic, negative 2.87, to the left one of the critical values, negative 1.86. So the test statistic is below the critical value. This tells me I'm in the tail. So the test statistic does not fall in between the critical values, and therefore we do reject the null hypothesis, and we say there is sufficient evidence to conclude that the mean ratings are different between the two brands. Now, what assumption is necessary about the population distribution? We have to assume that the distribution of the differences between the measurements is approximately normal. So that's choice B here. Now finally, well, hopefully finally, we're going to determine the p-value. So let's go back over to our Excel spreadsheet. The p-values are on here as well. So here's the probability that t is less than or equal to our observed statistic with 2 tails. So I have 0.0207, 0.0207. And I want 3 decimal places. So to 3 decimal places, it's going to be 0.021. And the meaning of the p-value, this is the probability of obtaining a sample mean difference that's at least as extreme as the one that we have above. Now we're going to compute the 90% confidence interval estimate of the difference in the mean ratings between the two brands. So we have to take this mu d, we have to add onto it the sample error, and multiply by the t statistic that we had. I'm going to pause this video for just a minute, and we'll pick it up in just a second. Okay, we're going to continue now, and this time we're going to find the confidence interval for our data. So here we have the different brands. Just hopping over here, what we need is the mean difference. This is the critical value that we have on our other slide. This is the standard deviation of the difference, and then the square root of n. So I'm going to use Excel to compute the mean difference and to find the standard deviation because we know what n is and we know what the t is. So we'll hop over into here and we'll have a new column, which is just the difference between these things. And we'll compute this as equals the first number minus the second number. Copy that down. Here's all of our differences. And then we'll compute the mean and the standard deviation. So for mean, we'll do equals average of all of these numbers. So that's the mean, and the standard deviation equals stdev.s for sample standard deviation of all of these numbers here. So remembering that our n is equal to 9 because they're listed right here from 2 through 10 is 9. So we're going to compute the low end of our confidence interval, which is going to equal the mean. And to get to the low end of the confidence interval, we'll subtract the t value, t critical value, times the standard deviation of the difference divided by square root of, in this case, n is 9. So there's the low end of my confidence interval, and for the high end of the confidence interval, we'll do exactly the same thing. We're just going to use a plus instead of a minus. So equals the mean plus the t critical to tail value times the standard deviation divided by the square root of the n, which is 9. So it looks like the low end of our confidence interval minus 1.464 and the high end of our confidence interval minus 3.1369. So we'll hop back over into our homework sheet and put in the low end of the confidence interval. See, they want it rounded to 2 decimal places, negative 1.46. And the high end of our confidence interval, negative 0.31. And that's it for this question. Hope this has been helpful, and I'll try to do another one for question number 4. Have a good night.